Good morning. Here's your objective for the day. I will be able to use the identity properties, which are adding zeros and multiplying by ones, to write equivalent expressions. Okay. So we're going to be looking at what happens when we add the opposites and what happens when we multiply by the reciprocals. So example 1, write the sum, meaning we're adding here, and then write an equivalent expression by collecting like terms and removing parentheses. So first we're going to write the sum, then collect like terms. So we are writing the sum. So we're basically just replacing the and sign with a plus. So 2x plus negative 2x plus 3. So we've written out the sum. Now we're going to write an equivalent expression by collecting like terms. So I have 2x plus negative 2x. 2 plus negative 2 equals 0. So I get 0x plus 3. 0 times x is just 0. So I get positive 3. That's as simple as I can get. For letter B, again, we're going to write the sum and then collect like terms. So 2x minus 7 and the opposite of the opposite of 2x. The opposite of 2x is negative 2x. I'm going to collect like terms, these two right here. Let's rewrite that, 2x plus negative 2x minus 7, or we can change this to plus negative 7. Again, 2 plus negative 2 is 0, so this makes 0x plus negative 7, which is just negative 7. Lastly, we have the opposite of 5x minus 1. So we just make that whole thing negative for the opposite. And we're adding it to 5x. So the opposite of this whole thing, first we're going to rewrite that subtraction. Plus 5x. Then we're going to multiply both of these terms by negative. We're not going to multiply this one because it's not in the parentheses. So we have negative 5x plus negative 1 times negative 1 is positive 1 plus 5x. I'm going to rearrange it. So we have like terms together, negative 5x plus 1. Negative 5 plus 5 is 0. So this gives me 0x plus 1, which just leaves me with 1. So here we were adding opposites to make zeros, and this really simplified our expressions. Now we're going to be multiplying with reciprocals. So just as a refresher, when we're multiplying fractions like we are here, we multiply the top and then we multiply the bottom. So 3 times 3 is 9, 4 times 4 is 16. When we have a whole number, we put it over 1. So we have 4 over 1 times 1 over 4. Multiply the top and multiply the bottom. And we get 4 divided by 4 is a giant 1. So we just are left with 1. Same thing here. 1/9 times 9. Put the 9 over 1. 1/9 times 9 over 1. Multiply the top, multiply the bottom. We get a giant 1. Okay, if we have negative numbers, negative 1/3 times negative 3, put the negative 3 over 1. We know that a negative times a negative is a positive, and we're left with 1 times 3 on the top, 3 times 1 on the bottom. 3 over 3 is just equal to 1. And lastly, again, we know that 2 negatives equal a positive. On the top, we have 6 times 5, which is 30. On the bottom we have 5 times 6, which is 30. 30 divided by 30 is equal to 1. So when we multiply by the negative, we multiply by the reciprocal, we are left with just 1. Okay. Now, here we have a slight combination. Write the product, so we're multiplying, and then write the expression in standard form, meaning we're going to distribute, we're going to simplify. Simplify. Okay, so first we have the multiplicative inverse of 1/5. That means that we're flipping 1/5, and we get 5. So the multiplicative inverse of 1/5 is 5, and this expression here. So 5, again, we're writing the product, so we're multiplying this number and this number, or this expression. Okay, let's do that for the next two, and then we'll go back and solve them. The multiplicative inverse of 2, which is, flip the fraction, 1/2. 1/2 times 2x plus 4. Again, we're writing the product, so we're multiplying the two terms. Lastly, the multiplicative inverse of 1 over 3x plus 5. We're going to flip that whole thing. That's the multiplicative inverse. And we're multiplying it with 1/3. 1/3 times 3x plus 5. So we wrote out the product, and now we're going to distribute. So for this first one, we have 5 times 2x and 5 times 1/5. We get 10x minus 5 times 1/5. Put it over 1, and we get 10x minus 5 over 5 is 1. Just to show that this equals 5 over 5, which equals 1. Oops, there we go. Okay, for here we have 1/2 times 2x and 1/2 times 4. 1/2 times 4. Put those both over 1, and we're left with 2x over 2 plus 4 over 2. 2x over 2 is just 1x, plus 4 over 2 is 2. 1x is the same as just plain old x, x plus 2. And lastly, we're multiplying with a fraction. 1/3 times 3x and 1/3 times 5. Put these both over 1. And we're left with 3x over 3 plus 5 over 3. 3 over 3 is just 1, so we get 1x plus 5 over 3, or just x plus 5 over 3.